Okay, so we've seen how getc works, getc, putc. Maybe you might have tried fputc and fgetc. You've also seen getcar and putcar for standard in, standard out. And you've used printf from pretty much the very beginning of C programs in this semester. Printf writes to standard out. You might say, well, is there something that to read from standard in? Sure enough, there is. You read input from standard in or the keyboard using the scanf function. So this works a little bit differently from most other functions that we've seen. It takes a format string, although it doesn't print anything out. Actually, you can print things out, but normally the way you use scanf is you're going to say what kind of things you're going to read and then where you want to save them. So it turns out these things in printf, we put stuff out to the terminal or to the console, to standard out, that is. But for scanf, we're actually getting things in. And so we're getting things in from the keyboard, and you can have any number of variables. And however many things you read will be returned as a int. But the thing is, scanf in effect returns a bunch of things in the variables, in this list of variables. So it returns more than one thing in some way. So you might ask, well, how can a function do that? It turns out the way it's able to return stuff is that you pass in pointers to things. So this is very different from functions that we've seen so far. So once again, scanf returns 0 if the input failed. That is, for whatever reason, you, let's say, said you were going to read an integer in the format string, but you actually got a letter or something, and so the input will fail. If it works, it'll return n, the number of things that it read. Or else it'll return EOF, that's end of file, if nothing was read and you encountered an end of file. Let's say you're reading from a file. Okay, so let's take a simple example. To read input from standard in, use scanf, format string, and a number of variables. So let's say we have two variables, both ints. Keep it simple. So we have two ints, int I and j. We don't have to initialize them because we're going to read in values using scanf. So now you say in the first argument, remember it's a format string just like a printf, and you give it 2% Ds, indicating that you're reading two decimals. So here is where everything is all different from what we've seen before. Remember the ampersand operator, it says address of. And so what you're saying here is you're taking the address of I and passing that into scanf as a parameter. Okay, so once again you're essentially passing a pointer to I, and scanf has a pointer to I, and so it can change the value of I now. So it can say, essentially, if it has a, and I'm making this simple, but if it has a parameter named x, and it's a pointer to I, it can say star x equals 5, whatever it reads from the input. So of course I'm simplifying it since it can be any type, it's not an int, and so it does some decision making based on the type and stuff like that. So all we have to keep in mind for this very simple example is that it's going to try to read two ints, and note that it skips spaces, tabs, new lines, all of those things it skips. You do need a space between the two ints. So let's just take a simple example and you'll see. So try this out, same kind of thing that I'm going to show you just now. So a very simple example like 17-6, I think. Yep, that's the one. So I have the same thing, same kind of thing that we saw in the notes, plus I added a printf. It says it read two ints from the keyboard, %d, that's I, and %d for j. Okay, so all it'll do is read things from the keyboard, and you have to see this to understand how it works. Try out simple examples, and then you'll get a feel for what scanf does. So I do want to warn you that once again, this program, when it runs, it'll be stuck here until you type in two numbers separated by some spaces or new lines or whatever. It doesn't matter how many you put in. And then once you put in 2, it's done. It's this call to scanf will be done, and then you go on to this and it'll print out the 2 ints. So let's try it out. First we have to compile it. Okay, it works, and let's run it. So I do want to say that most programs, before the scanf, they will have a printf saying enter 2 numbers, and that's considered more user-friendly. So we're just trying things out for the first time, so now we know that when we run this program, we don't get any indication of what we're supposed to do. Just so it turns out we have the code, and so we know that we're supposed to enter 2 integers. So you can type in anything, 1, 2, 3, 4, 5, 6. Okay, I wasn't looking when I was typing it. So now I hit return, and then it says read 2 ints from the keyboard, 1, 2, 3, and 4, 5, 6. So now you can try this out. So you really should try this out and see where the limitations are. So let's say we assume that we can type in 1, 2, 3 over here and 4, 5, 6 without spaces. Will that work? Turns out no. What it's done is it's read 1, 2, 3, 4, 5, 6 as one int and stored that in I. It's waiting for the second int. And so let's say put that in, and lo and behold, it thinks that the 1, 2, 3, 4, 5, 6 is one thing and 3, 4 is another thing. So I just want to point out that even though there are no spaces here, and you don't need spaces here, scanf really is expecting 2 different ints separated by any number of white space characters. I can show you to type in 1, 2, 3, 4, and I'll put a few spaces, and I put a tab, a few tabs, and then 4, 5, 6. If everything works, it should say it read in 1, 2, 3, 4, or 1234 and 456. So you can try it with 1, 2, 3, or I'm still stuck on those numbers. So you can put in any number of new lines and put in 789. Doesn't matter. It just says, okay, this is one int, and I'm going to ignore all of this. This is just white space. And so the next int is 789. And there. What happens if you don't put in an int? So then the program will crash. So let's say 1, 2, 3, and I put in R, 4, 5. I actually didn't crash, sorry. It just ignored this. It said, basically says, so R makes it so that you cannot parse it. So if you remember from your Java, if you enter a letter when Java is expecting an integer, oh yeah, Java crashes. C does not crash. It just says, okay, I'm going to ignore this. I can't translate that, so I give you a 0. Okay, let's try some more. Let's just type in all letters. They're both zeros. I'm trying to think if there's anything else. You can put in negative numbers. Negative 234. Okay, what's the limit? The limit, since we're reading ints, the limit is about 2 billion. Remember? Oh, I lost track. 1, 2, 3, 1, 2, 3, 1, 2, 3. That's about the largest number that you can read in. If you try to do something significantly more than that, like 2.5 billion, you will get a negative number. So remember, ints go from about negative 2 billion to positive 2 billion. It's somewhere between 2 and 2.5 billion, somewhere in there. And so the first number it read okay. So the 2 billion it read okay. The second number made it flip and turn around and give you a negative number. So there are limitations, of course. If you're reading ints, you have to, the numbers have to be between -2 billion and +2 billion. Actually, somewhere between 2 and 2.5 billion. So keep that in mind. If you want bigger numbers, you can always use longs. But I hope you get a rough idea of how scanf works. Basically, it returns three things. One is the return value, and in this case, it returns two things. Well, in general, you can read any number of things, so it can return n things, or however many things you have in your list of variables. You are not limited to just one or two variables in this list. Okay, so quick overview of the file versions of these functions. Just like you have getCar, you have getC, and fgetc works the same way. You have putCar for standard out, you have fputc and putc. Oops, I have these reversed, so sorry about that. This is reversed. These, I believe, are right. It's only fputc that works differently from the rest. So once again, fputc, the file star argument comes second. This is a typo mistake. Okay, just like we have scanf to read from standard in, you have fscanf to read from a particular file. That is, assuming that you've opened it and for reading, then you can use fscanf just like we did scanf. And as you can guess, just like we have printf, we have an fprintf to read from a file. So in this case, you have at least two arguments. First one is a pointer to a file. The second is a format string, and then you can have 0 or more arguments after that if you want to print specific variables, assuming that you have the right format string, like %d or whatever. So here's a simple example. Fprintf to standard out. Standard out means standard out. So this is not the name of a file. This is something that's in stdio.h, and it says if you do standard out, that's basically the same as saying printf. You're not really printing to a file. You're printing to a quote-unquote file called standard out, which is just the terminal. So fprintf to a standard out is the same as a printf. There's really no difference. So there's a bunch of character processing functions. It is blank will check if a character that you pass as parameter is a space or a tab. These are all defined in ctype.h. Some things can check for space. Alpha is alphanumeric. Oh, sorry, alnum is alphanumeric. Alpha is alphabet, checking if it's a letter, uppercase or lowercase. Then you can further check if a character is a lowercase character or an uppercase. Then you can also check if it's a number or digit or a hexadecimal digit, which would be a number or A, B, C, D, E, or F, upper or lowercase. Okay, so all of these functions return a 0 if false and something else, something other than 0 to indicate that it's true. So for example, if you ask is digit 9, this will return something other than 0, but you're not really always sure what it. Chances are it'll be a 1, but you cannot be sure. All you should check for in your code is it 0 or is it not equal to 0. Okay, so there are also functions to convert from lowercase to uppercase, to upper, and to lower converts the other way around. And there's a bunch of programs, and you want to take a look and see what this does. It's pretty straightforward. I would say just try these out. These are simple loops, and you want to try to figure out what these programs do on your own.